Okay. Hi, everyone. I'm Aymeric Fromherz, and to wrap up the first grade day of ICFP, I'm going to tell you about how this year's ICFP programming contest went. And to start with, I want to both acknowledge and thank my co-chair, Al Kelesh, who pretty much single-handedly designed and implemented our back-end infrastructure, and without whom this whole thing wouldn't have happened. So to start with, let me give you some context about the ICFP programming contest. So this is a contest that has been sponsored by ICFP and that has been happening yearly since 1998. And as a contest, it's something that runs over the course of 72 hours, with the first 24 hours that are what is called a lightning round, and then the next 48 hours where the contest is extended with more problems and more extensions to the initial problem. There are no limitations whatsoever on team sizes, so people are competing in teams, and no limitations on the programming languages that are used. So this year, the contest happened at the beginning of July over the course of a weekend. And one of the fun things about this contest is that organizers change every year. And because of that, you have a lot of variety in the problems that are tackled, problems that are proposed, and everybody can just come and add their own tastes and their own interests to the problems that are proposed. So let's talk a bit about this year's problem. As you might have guessed from the icon for the logo of the contest, this year's problem was about music, and especially about optimizing the placement of musicians on a stage so that you would maximize the quality of the sound in the room. So how does this work? Contestants were given as inputs first the topology of a room and the stage. So stage was considered to be a rectangular thing inside the room, and you would have, for instance, a stage at the top or a stage at the middle. There was a lot of variety in how the stage was placed. On top of that, you had the placement and some information about the attendees, so they would be spread out in the room outside of the stage, and you would be given some information about the musicians you had to place on the stage, so their number and also some extra information, such as the instruments they are playing. More information about this in a minute. Now, placing musicians, we had some constraints, such as, for instance, musicians are pretty nice, so you should put them on the stage. Musicians don't like to fall off the stage, so you shouldn't place them too close from the edges. And as musicians, we like to have some room, so you shouldn't place them too close from other musicians indeed. So for instance, this could be considered a valid placement where you have two musicians that are not too close according to some radius and are just placed on the stage. Now, how do you actually compute score? Well, the idea was to try to model and to mimic how sound actually works. So for instance, if you have a musician and attendee at a distance of, let's say, d, the scoring function from the sound quality for this musician to this attendee would be a function of something on the square root of d, on the square of d, sorry. And so all of this would involve a lot of floating point computations, which have been a lot of fun during this context. One interesting thing is that other musicians placed on the stage can actually block the sound. So here, in this case, you can see that the musician at the bottom is blocking the line from the musicians at the top to the attendee. And because of that, the attendee cannot hear the musician at the top. And as a simplification, we didn't consider that attendees could block sound. Only musicians could block other musicians' sound. So in addition to a musician's placement, each musician was also associated to an instrument. And each attendee has different tastes in each instrument. So for instance, personally, I really love both the piano and the bagpipes, but the bagpipes are kind of an acquired taste, and not everybody might be so happy about it, and some people might actually hate it so much that they would leave the room rather than hearing the bagpipes. So the taste of each attendee was actually a number that could be both positive and negative, and so in some cases, you could place musicians so badly that people would literally hate the concert. And so in the end, what this meant is that the musician attendee score was weighted by the instrument taste, and then the total score was just the sum of all the musician attendee tastes. So this was pretty much the basic problem that we proposed as part of a lightning round. And then for the next 48 hours, we also proposed a bunch of extensions to the problem. So this year, we decided to strike a balance between proposing new extensions and avoiding invalidating all the previous results. So we really tried to have all of the extensions that were backwards compatible so that people that didn't have as much time to do a full round would still be competitive and happy to have played the lightning round. So the first extension we proposed was that in addition to the topology of a room, you could also have pillars outside of the stage which could block the sound coming from musicians the same way that musicians could block each other's sound. The second extension was that musicians would actually play better when grouped with the same instruments. So for instance, if you have a group of fiddlers close to each other, they are very happy, they can listen to each other, they are happy to play together, so sound quality is going to be better. If you have a poor fiddler alone on its corner, well, too bad for him or her. And the last extension we proposed towards the end of the full round was that you could actually control the volume that musicians could play at, including completely stopping, completely muting one of the musicians. So altogether, this gave you a lot of flexibility in terms of how do you place your musician. Do you rather have some musicians that are not so good, but that are blocking musicians that are hated by the audience? So it gave a lot of flexibility and a lot of complexity to this optimization problem. Now, before going into the solutions that were proposed and announcing the actual results, let me give you some stats about the contest. So overall, we proposed a set of 91 problems over the course of the fall contest, which ranged with different characteristics and were pretty much all automatically generated according to some constraints. This year, we had 163 teams that entered the contest, and out of these, 158 that actually managed to score points, so submitted valid solutions at some point. Interestingly, we had about 15% of first-time participants, so that's been quite encouraging to see that it's not just always the same people that do ICFP programming contest every year, and that you have some newcomers once in a while. And perhaps the most interesting thing for me, we had a lot of solutions submitted, much more than we actually expected, to the point that our infrastructure started blowing up in the middle of the contest, and we had to upgrade servers live during the contest about 50 hours in. And in retrospect, that sounds obvious, but we really should have backed up the database before doing this upgrade. If you want to have a fun horror story, I'd suggest you talk to Alp at the reception tonight. It's been a fun 2 hours in the middle of the contest. And so, if you're interested by this whole thing, many of the teams actually submitted write-ups, wrote about the contest, wrote about their experience. Many of their code and their write-ups are publicly available on GitHub, so you're free to search for the ICFP'23 repositories on GitHub. Many of them are very easy to find. Okay, let's talk about some of the solutions and the actual technical challenges of this contest. First of all, even though it was an optimization problem, we tried to make a scoring function nonlinear because otherwise the problem would be much too easy to solve. In addition, as I mentioned earlier, the scoring function itself was heavily involving floating point computations, and some things I omitted in addition to the actual floating points, also some uses of ceil and floor functions all over the place. And that's been a bit challenging for some people to get it right. And apparently, despite saying, oh, you just have to follow the IEEE standards, that's not a valid answer for some programming languages. So that's when I was very grateful to have written this whole thing in OCaml, where you actually have a great floating point library. And on top of that, for an optimization problem, computing the scoring function itself was kind of expensive. So in terms of complexity, if you have m musicians and a attendees, the naive complexity for computing the scoring function was around m to the square times a, because you have to consider the pair of each musician and attendee, and then for each musician, check if another musician is blocking the sound coming from this musician. And so, as some contestants realized, you can actually do something slightly more effective with radial sweep, which gives you a better complexity and also allows you to iterate faster on the different solutions you're proposing. Now, what did solutions look like? Well, unfortunately, most of the top-scoring teams adopted pretty much the same solution, which is an optimization algorithm called simulated annealing. And the core idea, at least from what I understand, is that as a basis, use something called heap climbing for finding a local optimum. And to avoid getting stuck in a local optimum, once in a while, you do large transitions, which are going to put you further away from this local optimum and try to find a global optimum. And so some of the transitions that were considered by contestants were, for instance, swapping, starting from a related position, swapping to musicians, or moving a musician to a random place, or moving one musician as far as possible on the stage in one direction, while remaining a valid solution. And so unfortunately, other solutions were tried and proposed by several people, and despite being very successful early on, while simulated annealing didn't have time to converge, very quickly it got overtaken, and that's why most of the top-scoring teams ended up using similar approaches. Now, before giving the actual results, I just want to talk a bit about the fun part, which is seeing the contestants interacting on the Discord server that we set up. And there were lots of fun quotes, fun things that were exchanged on the server. So to start with, let's start with some quote. We had somebody that, after the release of a lax detention, stated, wow, I set bass solo to true, and the number of attendees dropped by 90%. You know, classical dislike of bass players. It's a standard trope. Why not? We had a second person who said, oh, some hate everything, but still went to the concert so that they can play. And to be honest, this one is on me, because I generated the problems automatically. There was one where nobody was happy about any of the instruments, and the score was always negative whatever happened, which was fun when you have the first top scoring teams that had negative scores and the teams that didn't have a solution yet were at the top of the scoreboard. So we fixed this live, but it was a fun time. And so in addition to a bunch of quotes, you had also many people that got very involved in creating visualizations of the problems. And so you had some cool stuff like this that I guess sends the radial sweeps of each musician, and also some people that really got into 3D visualization. And I really like the last one, which kind of looks like some hardware to me. And so on top of that, you also had some people that got creative solutions with interesting topologies. I'm not sure how that's optimal, but apparently that seems to be for one of the problems. And we also had a team that went very deep into creating custom solutions, and as far as I understand, that's the kanji for music, probably reversed. Okay, now to the interesting part, the results of the contest. So the first part is the winner of a lightning round, which is a team called All Your Sound That Belong to Us, and that stated that C++ is very suitable for rapid prototyping. All views expressed here are not mine, but just a result of a contest. As a judge's prize, we had a team called Coding Team, which are an extremely cool bunch of hackers, and decided to submit their solution in a mix of F# and Fortran. Unexpected mix, that worked for them, and they have an amazing write-up explaining pretty much minute by minute how they lived the contest, and it's been really, really fun to read afterwards. On third place, we have a team called Is Top Coder Dead, which stated that C++ is also not too shabby. On second place, we have Unagi, who stated that Rust is a fine programming tool for many applications. And on first place, we have a first-person team, first one-person team that also won the lightning round, which is All Your Sound That Belong to Us, and that therefore stated C++ is the programming tool of choice for discriminating hackers. Congrats to all of them and to all the contestants. So all the full results, the entire scoreboard, will be put online a bit later today. We froze it an hour before the end of the contest, but it should be up by the end of the day, in 5 minutes, even better. Okay, so to conclude, ICFP programming contest is tiring, but it's also a very, very fun experience for everybody involved. And if you like coding, I'd strongly suggest you participate so that we don't have to come on stage every year and claim at the International Conference on Functional Programming that C++ is the best language there is. That'd be helpful. Second, as part of the improvements for this year, we are also working on making it easier to organize contests in the future, and especially thanks to ALP, we are now having a rolling share system, which makes it much easier to propagate information, as well as a lot of effort in making the infrastructure and a lot of the things reusable across years. And finally, while we don't have a date yet for next year's programming contest, please stay tuned to both the website and the Discord server if you are interested, so that you can make sure to not miss it next year. Thank you.
All right, I believe we have time for some questions. If there are any questions. We're thinking. Well, I do have a question as a former organizer of the programming contest. The whole transition thing, can you elaborate a bit on that? How you're going to make it easier or more convenient for people to take up the mantle of hosting the contest?
Sure. So the rolling shares system is a first big thing in the sense that last year Alp was the main chair, and this year, I mean, he did a lot of work, but he also was very aware of what was work involved, what needed to be done when. So that's the first very valuable part. On top of that, we're trying to make sure that, for instance, the website stays the same and is easy to find, and also that a lot of the work is about infrastructure and backend, that this is also a set thing that you can just reuse and plug in new jerseys and new problems every year.
Sounds excellent. Simon?
Say anything about the, have I got to switch this on?
It should be okay to say.
Maybe it's okay. Okay, so anything about you said 143 automatically generated problems. Were they like 3 musicians and 4 attendees, or were like 3 million? What sort of scale? And so, was the stage little rectangular stages, or did you have, I don't know, lambdas or spiral stages?
So for the stage itself, we stayed rectangular because it was easier to have one set of, basically you could just represent it with 3 coordinates, like height, width, and where it starts on one of the corners. So because of that, we kept the stage pretty simple. For the number of musicians and attendees, it really varied from problems to problems. It was basically between 10 and 100 musicians and between 500 and I think 3,000 attendees. And then the problems themselves had different characteristics, such that you have mostly people that love every instrument that are close to the show, or stuff like that, for instance. So different classes of problems and several problems of each class generated.
All right, yeah. Lindsay?
Thanks. So first of all, thank you for organizing the contest. It must be an incredibly thankless job and huge amount of work. So this whole community thanks you. The ICFP contest is a treasure. But I just have one request, which is that next year you not put it in the exact 72 hours before the Popple deadline.
Well, you know, I'd have loved this myself, having submitted to Popple. The two together was a bit brutal. Luckily, next year's organizers are part of the functional programming community, but not academics themselves. So, you know, they might have a bit more flexibility. But that's something to keep in mind. Thanks.
Right, another question?
I was wondering if you had some stats on the number of submissions for the different kinds of languages people used all over.
So I don't have specific stats for this. What we've seen is a wide variety of languages, but still most submissions being in either C++ or Rust. We had lots of Rust submissions this year, which is why we'd love to have more functional programming submissions, including Fortran or not.
All right, any further questions? No? Okay, let's end it here then. Let's thank the speaker again.